It's about to start. We'll talk about code or whatever we'll talk about today. It's about to start, so please hang tight while I check that everything is okay. Sound check, camera check, lights check. How's my hair? Oh, wait, I don't have any hair. Maybe put some pants on and I am good to go. So get ready wherever you are, 'cause this stream is about to start. Get ready wherever you are, 'cause this stream is about to start. Hello everyone and welcome. This is day 14 of Advent of Code. I'm Leandro Facchinetti and here with me is David. Hello David.
Hello. I can't wave. My camera's not working, unfortunately.
What you're gonna do?
I'm here.
All right, and not only that, but you are driving today. So, yeah. Since your camera isn't working, I guess I will take you off of the overlay. It is what it is, and I'll switch to my screen. I will share my screen here on Skype and get to day 14. Let's go, people. Given that yesterday was easy, I think today is going to be hard, so let's get going.
Parabolic reflector dish doesn't bode well. You reach the place where all of the mirrors were pointing, a massive parabolic reflector dish attached to the side of another large mountain.
One of those.
Have a look at that. Got it. Beautiful. The dish is made up of many small mirrors, but while the mirrors themselves are roughly in the shape of a parabolic reflector dish, each individual mirror seems to be pointing in slightly the wrong direction. If the dish is meant to focus light, all it's doing right now is sending it in a vague direction. This system must be what provides the energy for the lava. If you focus the reflector dish, maybe you can go where it's pointing and use the light to fix the lava production. Upon closer inspection, the individual mirrors each appear to be connected via an elaborate system of ropes and pulleys to a large metal platform below the dish. The platform is covered in large rocks of various shapes. Depending on their position, yeah, we've got those hash symbols again.
No.
Depending on their position, the weight of the rocks deforms the platform, and the shape of the platform controls which ropes move, and ultimately the focus of the dish. In short, if you move the rocks, you can focus the dish. The platform even has a control panel on the side that lets you tilt it in one of 4 directions. The rounded rocks O will roll when the platform is tilted, while the cube-shaped rocks, where the hash sign, will stay in place. You note the positions of all the empty spaces with a dot and rocks your puzzle input. For example, this one. Start by tilting the lever so all of the rocks will slide north as far as they will go. I don't understand that. Start by...
So I suppose, like, for instance, here there are 4 round rocks, and if you tilt the thing north, then they are all gonna bump up here.
Oh, they all fall. It's like physics.
Yeah.
Wow. Okay. Start by tilting the lever so all of the rocks will slide north as far as they will go. You notice that the support beams along the north side of the platform are damaged. To ensure the platform doesn't collapse, you should calculate the total load on the north support beams. The amount of load caused by a single rounded rock, O, is equal to the number of rows from the rock to the south edge of the platform. Okay. Cube-shaped rocks don't contribute to the load, so the amount of load caused by each rock in each row is as follows. So 10, because it's the sum of... Oh, let me just open this one sec. Why is it 10? So there's 4 there, 5, 6, 7, 8, 9, 10. And
I
then...
think it's just counting up, right?
Oh, yeah.
It's just counting up the number of rows from the south edge. So, for instance, this rock contributes a weight of 9 because it is 9 rows from the south edge.
Got it. Okay. Yeah, it just happened to also be the number of rocks connected to the is the south in the north of the screen as well, I guess.
Yeah.
Yeah. Okay, the total load is the sum of the load caused by all the rounded rocks. So 10 times 5, 50, and then 2 times 9, and so on. Is that right?
I suppose we will count every rock, but let's double check. So this would be 10 times 1, 2, 3, 4, 5 plus 2 times 9 plus 1, 2, 3, 4 times 8 plus 3 times 7 plus 4 times 3 plus 3. 1, 3, 6.
Okay, so it does work. Good. Let me just grab this. Oh, I made a visualization, by the way, which I'll share with you another time.
A visualization for what?
For day 10.
Ah, the maze, the pipes.
Yeah, I implemented the diagonal thing.
Cool.
So we are day 14. Yeah.
Yeah, and I want to see, in this case, we don't have several small puzzles. We have one big board. One big board.
Ooh.
So it's big, but it's not so big. It's completely brute forceable, right?
Yeah, always. When have we not tried brute force?
And if brute force doesn't cut it, we will memorize. And today you are driving, so I expect you to send me the link.
I have done that.
We got a very doable problem today. You will like it, Nick says. Great. That's what I want to hear. Doable.
So the first step is to make this like this, right?
Ah, you already shared the link.
Yeah.
Give me 10 seconds to join. And I will try joining from the browser. No, I associated the link to Visual Studio Code, so it's gonna load here. Okay, I'll load as usual from here. But I suppose that maybe the browser is better. It's less prone to sync errors. I
doubt it.
I am in.
Okay, so
wait a second. .js? Are you doing JavaScript?
yeah, I'm on that level today.
I don't know what that means, but let's go.
So, is that the goal? The first part will be to translate this into that, right?
Yeah, I agree with that.
So I will just go through each. Do I have to manipulate it? Yeah, I guess I will move from the south and keep moving them up until I see a rock, I suppose. And I'll do that. So like, I'll iterate column by column. From the bottom up.
From the bottom up. Interesting.
No?
Go ahead.
And
Continue.
And then I will move. Maybe it makes sense to iterate from the top down, because if I'm iterating from the bottom up, then well, I could iterate from the bottom up and then just keep collecting in the buffer until I hit a hash. Like collect round rocks in a stack or in a queue. I guess it doesn't matter. In an array. And then move them and then insert them when I hit a hash. That's the general idea.
Can I present a different idea? See if you like it better.
Yeah.
How about we turn one column into a string? So this, for instance, would be turned into dash.
Yeah.
Then we use a regular expression to find dot followed by any number of dots and capital O or 0, I'm not sure. I think it's a capital O. And replace that with capital O followed by the number of dots you found. Of course, we also have to take into account the hash and do that as a global replacement and all that stuff. But
yeah, I guess we'll have to have multiple groups and then find out the indexes of the hashes.
Yeah, something like that. It's just a
because, for example,
hacky way of doing it, I guess.
If you had this kind of thing, you need to make sure that you separate it by hashes.
Fair enough, yeah.
Which is tricky for me, regex-wise. But I like the idea of manipulating a string.
Well, the hashes are not so difficult to deal with if your regular expression is accepting only capital O and dots.
Yeah.
It will not even touch the hashes.
Yeah. And then I guess you need to find the indexes of those. I like the idea of manipulating a string as well. And then we will have to transpose it afterwards. Would it not be easier to split on the hashes and then manipulate it that way?
Perhaps,
and then transpose it again. Yeah, I think I'll struggle with the regex. But I'll transpose it in the way that you. How about that? It's like a hybrid. We can always try the regex a bit later.
Yeah. Carry on.
Okay, so transpose the board. Well, that means that this doesn't work. What's this exactly?
It's getting rid of empty lines.
It's not exactly what I want. So split on new lines and then that will give us, that will give us the rows. But we need to also then split on that, and then so we need to iterate via I'm struggling today. I'm not seeing it. I guess we need to iterate by I'm not seeing it today. So this is going to be like pairs of columns and rows. So it's going to go through each row and then every column. That's not what we want. Do I just need to switch these around? And then go through each. Is that right? To iterate the columns. Yeah, that's right. And then does that look right for transposing it?
I suppose, can you print?
Yeah. I need to run this file. Oh, 1 sec. As you can see, I'm a little bit slow today.
It's day 14. All our brains have fried at this point. Don't worry.
I'm not even printing it.
That's Python.
Oh my god, I'm writing. Does that look right?
I don't see the terminal, but I will let you decide if it looks right.
Yeah.
Okay.
Yeah, that's right. So that's the first row. So iterate through each row and split on hashes, and then within the groups count the round rocks and dots, and then rearrange, kind of thing. That's my general goal. So I appreciate your patience with me today.
Hey, take it easy, David. Take it easy.
Yeah. Okay.
And this is, wow.
What is this?
This is really cool.
Was it? I didn't even read
I
it.
don't know. It's just that you wrote a lot of code.
That is exactly your description, wasn't it? I don't know. That's not what I plan on doing. So yeah, the row is going to be that. And then groups is going to split on the hashes. And then
that answer that Copilot gave was surprisingly accurate, as if it knew the problem statement. Because it's looking at the round rocks. Look at that variable name, round rocks. Did we even mention rocks anywhere else?
Yeah, I did up here. Look.
Ah,
Yeah, and there. But I will soldier on with the with my implementation. So yes, I'm going to split by the hashes.
how did you know that the round rocks were the capital O's? You didn't say that anywhere.
Well, that's Copilot for you.
I suppose it
magic.
is being informed by other people using Copilot in Advent of Code.
Mm.
I mean, for instance, this
No,
line that
I don't think so.
this input that we copy and pasted here, because at
I
this
don't think
point
so.
there is plenty of solutions for Advent of Code in GitHub. So if it's using the latest data,
No, I don't think so. I don't think it syncs that quickly.
so
With,
how does it know that the round rocks are represented with capital O's?
I think it's a guess.
Suspicious. How does it know to split
What-
the
no,
groups with the pound? Or
Look at
hash?
this. Collect round rocks in an array, then insert when I hit a hash. So I'm saying that the round rocks are not the hash here. Maybe that's enough.
Very
I mean, the
suspicious.
question is, would you be able to work this out from my comments?
I probably not. Probably not. I probably would need to know the problem statement.
Yeah, I wonder if it's aware because this is Advent of Code. It's like, oh, I know how Advent of Code do their things. I don't know.
Maybe.
So for so what I'm going to do is const new groups equals groups dot map. So I'm going to count. You see how it's trying to do regex? That's based off of saying regex, isn't it? Well, we didn't even say regex.
I said it out loud. Maybe it's listening
Yeah.
to the Skype call.
Yeah. I will go with that. Is that right? I think I'm just gonna. I don't know if that's right, so I'm just gonna do it like this.
I think instead of match, it should have been match all, and then it would have been correct. Correct.
Yeah, but I'd still have to destructure the groups and stuff. This is simple enough. Count round rocks, and is there a there's a fill, I think. So I'm gonna do return O dot repeat. Yeah, that looks right. And then yeah. And then it's like that. Is that right? Why is it throwing? Oh yeah, it's because I'm redefining new board. I'm just gonna YOLO and do global variables.
Let's go.
So now we have things correct, but in the wrong order. I can still actually probably, for this answer, I probably don't need to. I don't need to flip it again.
You do not, because next is to count the points.
Yeah. However, I'm just going to do board equals new board. So I'm not going to flip it, but I am going to iterate it like this. And sum equals 0. And then the factor is going to be height minus c. Is that right? Or is there a +1?
Given
off
our
there?
transposition, are we talking about width now?
Yeah, so we're going to have to go... Here I'm going like... Because we need to count it in rows, right? So now I need to count it in columns. If you see what I mean.
Carry on.
Yeah, so I just need the height minus I just need to see that diagram of Advent of Code where it shows like how it's counted. That's this one. So if this is the first, I think it's going to be this. So this is going to be like the 0th. I'm just going to say that's right. And then we'll find out if it's right. So all I need to do is count the number of O's here. And then by that. And I'm just going to print so I got 44. That's wrong.
Do you really need the +1 in line 175? I feel like you shouldn't need. Because the height of that example was 10, and then 10 minus 0 gives you 10.
Oh yeah, I didn't print the answer. 121, is that the answer?
That is not. It's 136.
Okay, so maybe it is a +1. I think it is a +1, but I'll have to think about it more. I got 139.
It's closer. What does the board look like after the processing?
Oh yeah, I didn't verify that at all. I'm gonna do does that look right?
I don't have the terminal. Can you copy and paste?
I think I'm doing it the wrong direction.
Well, that looks about right, but you have some extra O's in there.
Does that look about right?
Let's see the transposed board, which we believe in.
To transpose it again?
No. I mean, maybe we could do that. No, it's just that I wanted to see the before and after side by side, and then we would be able to tell if it's right or not.
Okay, I see.
Yeah, that will do it for me.
So this is before.
So it is doing the right thing of accumulating all the weight on one side.
Yeah.
And it is...
It looks right. To me.
1, 2, 3, 4, 5. And in the original example, we had 1, 2, 3, 4, 5. Yeah, that looks about right.
So yeah, the factor is definitely wrong. So that's the correct factor.
Great.
And so there's like, it's saying 121. So this is what it's saying.
So there are 4.
Which is correct. 39,
Here.
38.
No, wait a second. I'm getting confused by the transposition. I count 5 here. This is not right. 1, 2, 3, 4, 5.
Where's the 5?
This.
Um, 1, 2, 3, 4, 5. Oh yeah. Okay, so is there something wrong with this?
And in
And
the
is it
original
always
there
up-
were 5, so that's all right. That's correct. But the counting is
Yeah.
wrong. So
Yeah,
maybe
so
you
it's-
shouldn't start the count rocks with 0. No, you should. You should.
There's just something wrong with this. Probably with this iteration.
Probably. Are
So
you
I'm
sure
going
that
to-
you don't want to swap width and height, given that we transposed the matrix? I know I said this before, but it feels like this could be the problem.
Yeah, that makes sense. Should I transpose it again to make my life less confusing?
I don't know. I guess transposing it to begin with was the problem, right? What did we gain from transposing?
Yeah. Not much. Yeah, that's wrong. I wonder why am I even doing this, to be honest? Because C equals, this should just be the board 0.length, and this should be board length. Let me log these rows.
And are you sure that the C and the R aren't swapped here in the board?
No, not really. That looks wrong. Yeah, that's the answer.
Oh, do we
Okay.
get 136 now?
Yeah, now we get 136.
Oh, great.
Great.
Can I paste in my inputs?
Of course, yes.
Okay. My input is in. You may run the program.
Okay, that worked. 110799.
110799.
Yep.
That's not the right answer. Your answer is too high.
Oh.
Oh no.
Oh no.
Maybe I copied it and pasted it wrong. Or I typed it wrong.
I struggle to see how you could have done that.
Yeah, I need to wait 30 seconds and then I can verify. Because I feel like I wrote 799, not 779. Maybe that's that.
Yeah? Shall I try mine and see
Go
if
ahead. Yeah, try yours. While I am
before
waiting.
waiting?
And meanwhile, I'm going to stare at the inputs and see if there are any weird edge cases.
Please work. Yay, I got a gold star. I think you probably typed it wrong.
I probably typed it wrong. Yay! I typed it wrong.
Yay.
Good
That's a
job,
relief.
ourselves. Good job, David.
Well, yeah. Okay, let's have a read of part 2. Part 2, the parabolic reflector dish deforms, but not in a way that focuses the beam. To do that, you'll need to move the rocks to the edges of the platform. Fortunately, a button on the side of the control panel labeled spin cycle attempts to do just that. Each cycle tilts the platform 4 times so that the rounded rocks roll north, then west, then south, then east. After each tilt, the rounded rocks roll as far as they can before the platform tilts in the direction after 1 cycle. The platform will have finished rolling the rounded rocks in those 4 directions in that order. Here's what happens in the example above after each of the first few cycles. Right. I think it was stupid to transpose it now.
Well, you
Because-
say that, but transposing is really neat because we have done a roll to, let's say, the left, right? So we transpose once and we get the north on the left, and then we do the thing. But because we have the transposition code, we can just do it again, and then it's gonna be either north, either west or east. It's difficult for me to tell, but the transposition is not wasted because we will just transpose, do it again, transpose, do it again, transpose, do it again, right?
Yeah. So we can just abstract, transpose into a function and tilt into a function.
Well, it all depends on. There are 4 transpositions before we complete a cycle, or there are 4 transpositions first to complete one cycle. Then they want us to keep doing cycles. If they want us to do, like, let's say, 1 billion cycles, perhaps it's not the best thing for us to be transposing matrices 1 billion times.
Oh, well. Wait, so they just want us to repeat, like, north, south, east, west 1 billion times?
Yeah.
Won't it just, like, after the first few cycles?
You think it settles down?
Yeah. We could always cache it.
I like the way you think.
Just memorize it and see when it cycles, and then just, like, multiply it, put it through the index. Like, store each board as we go. This seems pretty doable.
Yeah, if there is really a pattern to the problem, it seems really doable. What I'm doing here on a separate buffer, which you may not have access via Visual Studio Code, but you will have access via the Skype share, is if we can spot, by seeing the boards, if we can spot a pattern. And I can see some patterns. For instance, these 2 guys, they stay where they are, and it stands to reason that they will continue there. And this guy here at the bottom seems to come in and then go off. And it stands to reason that perhaps they would do that again and again. So, yeah, maybe there is a pattern that emerges after enough cycles. And perhaps doing the memorization would work, because then we don't need to think about how the cycles come about. We can just use the memory on the computer to figure that out for us, right?
Yeah. I have to say, Leandro, I'm feeling pretty ill. And I don't have the energy to complete this today.
Okay.
However, I don't know what you prefer. Feel free to carry this on without me. I'll probably be lurking on YouTube or sleeping. Or we can always continue it tomorrow. But yeah, up to you. Probably you have an idea in your mind. But I think I'm going to head off and be glad I managed to get part 1 done.
Good job on part 1. And for tomorrow, do you want to do Advent of Code at all? And if so, do you have a preference, morning or evening?
I definitely do. And ideally around midday, 1 p.m. Midday sounds good to me.
So 1 p.m.
Does that work for you?
UTC. Yeah, okay. I will take note here so I don't forget. But 1 p.m. UTC. And I will not solve the problem. I will let you drive tomorrow at 1. And it seems like a fun little challenge here. I think it seems doable, like Nick said. And
yeah.
And with that, I suppose we can get out of here. So thank you to... Well, let me go back to the screen here.
Hey,
thank you to Nick and Bo and Fogis for joining us here. And let me quickly address any comments or questions. Bottom up is a bad call, as you will encounter all the rocks in between. Sure, that will work. Too quick to judge. Yeah, I don't know what happened to David's camera. We tried turning it off and on again, and it didn't work. The regex mesh is a funny exploit. I like it.
I am curious to read their code. I've deleted it now, though.
No, I think it was commenting on my idea of using the regular expression to do almost all of the problem with a search and replace. Columns would be width, rows height.
Yeah, I think he probably spotted the issue with my iteration.
You have some auxiliary tools for Advent of Code. I will want to see what you have in your toolbox. It seems like everyone who does Advent of Code for long enough will start developing a toolbox. And there are even scripts that download the inputs for you and all of that, because if you want to go to the leaderboards, you have to do everything very fast, of course.
That's why I generally prefer Python, because it has all those iter tools and things ready.
Fair enough, fair enough. You're studying 3D audio. Interesting stuff. All right. So everyone and me is wishing that you get better soon, David. And I'm looking forward to seeing you tomorrow at 1 p.m. UTC for the rest of day 14 and day 15 of Advent of Code. Let's say goodbye and I'll see you tomorrow. Bye.
Bye-bye. Thank you. Bye-bye. Good night.
Thank you for watching the stream, you know how great it has been. Or maybe it sucked, and I am glad that you stuck with me. And soon we'll all be back together for some more coding or talking or chilling. The next time I'll be streaming.